Perfect. If we want left, this is the left. And you cannot touch this. If you say the right will be this, 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 and this, and you cannot touch this. Good. So the base for all of them is 2 times the function f of 2 plus f of 4 plus f of 6 plus f of 8. That's it. So I plug in 2 in the function, I plug in 4 in the function, I plug 6 in the function, 8 in the function, I add those quantities, multiply by 2, and I get a number. Okay? And that is the approximate total cost between these two using 4 subintervals. This number. How I want to show you how I would get this number. Do you want me to record in Zoom these steps with a calculator?
Please.
Of course. Where is my recording? My recording, record. Yes, and I'll send it to you. Okay. So, it will help if I share, right? Where's my share button? I lost my share button. Wonderful. Oh, here it is. Okay. So, this is what I would do. I go to Stats, Edit, Clear. 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 Oh, okay. Clear. Okay, good. So I will enter 2, 4, 6, 8. That's my X. Oh, no. 4, 6, and 8. Here's my Y. Here's how I will enter Y. I will highlight the name of the list. I will put 2 in front. I will open the parenthesis, and I will put the function as 0.01 times list L1 to the 4th power. These are all my X's. They're in list L1. Then minus 1.44 list L1, of course, my X, squared. That's the function. And then plus 60. And close. So what does this do? When I click enter, it calculates 2 times f of 2 and puts it here. Then 2 times f of 4 and puts it here. 2 times f of 6 and puts it here, and so on and so forth. When I click enter, I get all the answers done at once. Then I will exit, and I go to stats. And now I want to do calculations. And I want one variable stats on list L2. L2. And I want to calculate. And I only need the sum, just this. And I don't have to calculate anything by hand. So the answer is 247.68. Do not copy anything else from those numbers. All we need is the sum. So I will not enter 2 in the function and then 4 in the function. It will take me 15 minutes to do that. So again, what I did, and I'm going to stop the recording now. What I did, I entered this list, and then I gave the calculator the command to create 2 times this, 2 times this, 2 times this, 2 times this. And then with stats, one variable stats for list L2, I copied the sum. Not the X bar, which is the mean, nothing else, just the sum. And it will take you 3 minutes, 5 at the most. But if you want to enter each and every number and then add them up and maybe make a mistake, who knows? Unless you enter the function. If you enter the function in y equals, maybe you'll get the same thing. Good. Any questions on how to approximate an integral? So we approximated the total cost, assuming that this is the cost function. If it's the revenue, I'll approximate the total revenue, and so on and so forth. Good, it is recorded, so I will send it to you. Next topic. So again, for that, you will only have 4 numbers to deal with. Because you know how to calculate or approximate the area with 4 numbers, you will know how to do it with 100. So 4 is more than enough. Good. Anything else? Okay, I will choose the next one. I will choose the average value of a function. So I'm given a function. Let's suppose the function is f of x equals e to negative 4x. And I'm asked to find the average value on a 1, 3. In order to find f average, I have to write 1 over 3 minus 1, which is 2, the integral from 1 to 3 from this function, dx. So then 1/2 in front. The function that I differentiate to get this is e to negative 4x over negative 4, and from 1 to 3. Of course, I will simplify by writing this, and then I will plug in 3, e to negative 12, minus, when I plug in 1, e to negative 4. You can change it, but don't do anything else, as 1 over e to the 12 minus 1 over e to the 4. That's good enough. And that was the average value of a function. I can consider that we also looked at definite and indefinite integrals, unless you have other examples that we need to look at. Would you like to look at some antiderivatives? They are the same with the indefinite integrals, but would you like to look at an antiderivative?
We did another example of definite and indefinite integrals.
Yes. So this is what we had: the indefinite and the definite. But if you want more examples, we can. So these are the definite and indefinite. This is the indefinite and substitution, and this is the definite and substitution. Always remember one thing. Let me refresh your memory. Any definite integral from a to b from f of x dx requires that the function exists, of course, and is continuous on the interval a comma b. This is a must. This is a very important condition. Always. Good. So you would like to choose other. You want other definite and indefinite without the substitution rule? Is that what you had in mind?
No, we can move on. I forgot we did other examples.
But we can, if you'd like. Let me open on. Where is my book? Okay, so let's open just in case. That was in the first section in 4.1, and that is on page 392. So see if there is something else. So these are the indefinite, and these are the most general antiderivatives with conditions. So these are the most general antiderivatives, and this one is with the conditions, so we determine C, the constant. So see if there is anything that catches your eye. And that will take care of the antiderivatives as well.
Can we try 49?
Yes, of course. So let's look at 49. I think I'm on page 6. Let's take a look at 49. 49. 49. Okay. So we have f prime of x is x squared minus 4, and we are given that f of 0 is 7. So first we will determine the most general antiderivative, which we know is denoted in this case by f of x, which is x to the third over 3 minus 4x plus a constant c. This is the most general antiderivative. But now when I plug in 0 for x and 7 for y, 7, 0, 0 plus c, then I determine the constant, and now I have a unique function. Not the most general antiderivative, but just one, x to the third over 3 minus 4x plus 7. So this is the only function that has this derivative and passes through the point 0, 7. There is no other. Okay. Any questions? Do we need to look at something else? Okay. Anything else you would like to pick?
Can we look at another example of the average value?
Yes. Yes, would you like to choose one? So the average value is just a formula. So if I have f of x, whatever it is, on the interval a comma b, f average is the 1 over b minus a, the integral from a to b from f of x dx. So that's just the formula. So once we have the function, we put 1 over b minus a in front, and we just determine the definite integral. You can choose any function you want.
No, that's perfect. Just the formula works.
Yeah. Good. Anything else? This is the consumer surplus and the producer surplus. Differential equations. How to evaluate and find the domain of a function of two variables. The partial derivatives, we looked at an example, the d-test to find max min. Area enclosed by graphs or functions. And properties of the definite integrals. What do we continue with?
Can we do the area enclosed by graphs?
Yes, of course. Good, so let's open, that was on page, I think it's 4.3. Yeah, no, I think it's in 4.2. Definite integral. Okay, page 425. Okay. Would you like to choose, or I will?
Can we do 12?
Yes. You want 12? With the area, with the graph? We did this one. I'm thinking of the one that you have to graph it. You have to graph, you have to find points of intersection, you have to shade in yourself, and you have to find the area.
Can we do 17?
17, perfect. So in 17, we have y equals x plus 2. And we also have y equals x squared. Good. So we know from a long time ago how x squared looks like. No problem. This is x squared, y equals x squared. It's a parabola, vertex at the origin, opening up. In other words, having a minimum. So this is it. Now this one, when x is 0, y is 2. When x is 0, y is 2, 0, 2. And when y is 0, I have to move to the other side. X is negative 2. So negative 2 comma 0. So negative 2 comma 0 is here, and 2 comma 0 is here. So I'm going to have to graph, and then I'll see the area is shaded in. Before I do that, I know that the two functions will intersect. They will intersect here and somewhere here. So y and y, I set them equal to each other first. X squared equals x plus 2. I have to determine the points of intersection anyway. It's quadratic. I have to set it equal to 0. I have to factor. So when I factor, I get x minus 2 and x plus 1. Or x equals 2 and x equals negative 1. So now I'm coming back to my graph. And I will find and shade in the area. And also, I also have the x coordinates. So this is the area. And I have a negative 1 right here, between negative 1 and 2, right here. So I already know that this area is found between x equals negative 1 and x equals 2. Of course, to be exact, I have a coordinate system. So then I know that the enclosed area is the integral from negative 1 to 2 from upper minus lower dx. So negative 1 to 2, upper. We should always write on the graph what we graphed. So y equals x plus 2, because it's easier to identify. So it's x plus 2 minus x squared. Good. So this is x squared over 2 plus 2x minus x cubed over 3 from negative 1 to 2. And you should always check this. I'm asking you to present exact answers, but you should always check it with a graphing calculator, because it's important not to lose points, right? So 4 divided by 2 is 2, and plus 4 minus 8 over 3 minus, careful now, when I plug in negative 1, 1/2 minus 2 plus 1/3. Now, I'm okay if you remember, I don't want you to spend time on arithmetic. So if you leave it as is, and then you put the final answer, but it has to be in a fraction form. With a graphing calculator, I'm fine. I can stop because it's not a lot. So 6 minus 8/3 minus 1/2 plus 2 minus 1/3. 6 plus 2 is 8. Negative 9 over 3 is minus 3, and minus 1/2. So this is 5 minus 1/2, so it's 9/2. So you should always check with the graphing calculator to make sure that that is correct. So I can do that too, but I don't really want to waste time on that. But let's do that. It's number 9. So this was from -1 to 2. And that was from x plus 2 minus x squared. Of course, dx. And if I don't get 4.5, then I know something is wrong and I have to go back. Okay. That's what you need to do. Shade in a graph, shade in, find the points of intersection, and integrate.